We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
When you look up at the night sky, you see a lot of things glowing, like stars, planets, and galaxies. So it might sound strange to hear that most of the universe is actually dark. The truth is, the protons, neutrons, and electrons that make up everything we can see, and that means everything with telescopes we've got, accounts for only about 4% of the mass and energy of the universe. The rest is dark and mysterious. More specifically, about 70% of the universe is known as dark energy. About 26% is so-called dark matter. The tricky part about this dark universe is that astronomers can't directly see any of it. They can only witness the effects these strange substances have on the material around it through gravity. Fortunately, modern-day astronomers have developed many tactics to explore the dark universe, including using telescopes like Chandra. Let's start with dark matter. Dr. Peter Edmonds of the Chandra X-ray Center gives us a quick overview about this mysterious stuff.
Scientists have known about dark matter for decades, but are still struggling to figure out what it is. We know some things about it. It acts like regular matter when it comes to gravity. But unlike normal matter, dark matter gives off no light. Because of this, we know that it has to be very different from the stuff in stars and planets and us. One way we can try to learn more about dark matter is to study clusters of galaxies. In fact, galaxy clusters gave the first evidence for the existence of dark matter back in the 1930s. The galaxies in galaxy clusters are moving around so quickly that there has to be a lot of extra matter, invisible matter, in clusters to hold them together with their gravity. It turns out that most of the normal matter in galaxy clusters is hot gas that can be seen with an X-ray telescope like Chandra, but isn't visible with optical telescopes. But there's still not nearly enough mass in this hot gas to hold all the normal matter together.
Just as astronomers were getting used to the idea of not knowing what dark matter is, they got a completely new and different surprise at the end of the 20th century. Instead of slowing down after the Big Bang, the expansion of the universe was found to be accelerating. Astronomers quickly did what they always do when they come up with something mysterious. They gave it a name. Now we call whatever is pushing the universe apart dark energy. But the truth is, no one knows what it is. Again, the good news is that scientists are using telescopes like Chandra to begin to find out.
Dark energy was originally discovered by optical studies of supernovas, and there is a lot of ongoing work in that area. But dark energy is a big mystery, perhaps the biggest in all of physics, and so you really want to study it and attack it with everything you've got. Clusters of galaxies are great tools for studying dark energy for a bunch of reasons. One is that you can use them to get good estimates of how much matter there is in the universe. This helps in working out how much dark energy there is. They can also be used as distance indicators, so people can cross-check the work done with supernovas on measuring the expansion of the universe. New Chandra results have just come out recently using this technique.
A lot of work has already been done to study dark matter and dark energy, but there's still so much more to learn. In fact, science may just be at the beginning of understanding what this dark universe is really made of. And scientists already have a lot of good ideas of how Chandra might be able to make a dent in these big questions in the near future.
One special area of interest for future studies of dark matter with Chandra are galaxy clusters which are colliding with other galaxy clusters. In the more violent cases, like the Buller cluster, dark matter can be wrenched free of normal matter, which doesn't normally happen. This helps you study some of the interesting properties of dark matter, like whether it interacts with itself at all. As for dark energy, very interesting studies are currently underway to look at how galaxy clusters grow with time. It looks like galaxy clusters haven't grown very much over the last 6 or 7 billion years. It could be that dark energy is limiting the growth of these objects in recent times. So this is another way to look at dark energy, and it's completely independent of techniques that measure distances and the expansion of the universe.
It seems like every time we make a new discovery about the universe, it leads to so many new questions. At this point in history, questions like, what is dark matter? And what is dark energy remain wide open. Thankfully, we've got tools like Chandra to help us try to answer some of these questions. In doing so, we not only expand our understanding of the universe we can see, but also for the universe we can't. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.